Hello to all. This is Dr. IJR initiating online lecture series on operations field. Today we are going to discuss about dominance rule of game theory. So before entering into the topic, first we may start with one problem. See, in this problem there are two players are there, A and B. A is following 5 strategies and B is following 6 strategies. So once we got this type of problem, first we may try to identify the saddle point of this matrix. Let us do the process by adding one column and one row under the name of row minimum and column max. Under row minimum, we need to identify the minimum number of first row, that is out of 420211 of A1, 0 is the minimum. We need to write down the minimum. And the second one, the minimum is 1. Third row minimum is -5. Fourth row minimum is -1. Fifth row minimum is -2. Out of this row minimum, we may find out the maximum number. So 1 is the maximum number. This is referred as maximum. Now comes to the column maximum. So under column maximum, identify the maximum number of each column. So first B1 column, the maximum is 4. B2 maximum is 3. B3 maximum is 7. B4 maximum is 3. B5 maximum is 2 and B6 maximum is 2. After completion of this process, again we need to identify the minimum number of maximum. So what is the minimum number of column maximum is 2. So this 2 is referred as minimax. So maximum is 1 under A2 and B3, and here minimax is 2 and 2. There are 3 2's are there under B5. We may round off this one. And B6 there are 4 2's are there. We need to find out. So maximum value is 1, minimax value is 2. That means maximum value is not equal to minimax. So again without saddle point. Without saddle point. So now it is not possible to us to find out the value of the game. So this is the basic type of calculation. Okay. So once we find out that a game without saddle point, so now we have to use the dominance principle. See, there are some points we need to keep in our mind. The first one is, if we didn't get saddle point, then we have a perfect option in front of us, that is apply dominance. Now the question, why to apply? The simple answer is to reduce the matrix to the following form. First one is 2 by 2 matrix. So if we successfully reduce the given matrix under 2 by 2 form, we have to use algebraic method, arithmetic method and formula based method. The second one, if we successfully reduce the table by 2 by n, that is 2 rows and n number of columns. In this case, we have to use graphical method. Once we apply graphical method, so we have to reduce the matrix to 2 by 2 and apply the above methods. And the third form is m by 2, that is n rows and 2 columns. In this case also we have to use graphical method and apply any of the above methods. And there is one more form is also there, that is if we didn't get the above forms after application of dominance, in the case that is for m by n matrix, that is m rows and n number of columns. So in that case we have to apply LPP method. So this type of point we need to get in our mind. now we need to see what is the dominance rule. See, what is the dominance rule here is the rule of dominance are used to reduce the size of payoff matrix. So basically the dominance rule is used to reduce the size of the matrix. Second one, these rules helps in deleting certain rows or columns of the payoff matrix which are of lower priority to at least one of the remaining rows and or columns in terms of payoff to both players. So what is the meaning of this particular point is we have to reduce the matrix by deleting certain rows and columns. Third one, rows or columns once deleted will never be used for determining the optimal strategy for both the players. And the last point is this concept of domination is very usefully employed in simplifying the two-person zero-sum game without satisfying. So this is the last and very effective point. That is, it's a game without a saddle point. In that case only we have to apply dominance rule. And now what are the rules of dominance? The first point is if all the elements of ith row are greater than or equal to the corresponding elements of jth row, then ith row is dominated by 0. So in simple sense, if we are dealing with a row, the highest values of row can be dominated the lowest value of the row. Second one, if all the elements of rth column are less than or equal to the corresponding elements of any other column, say S column, then rth column is dominated by S column. In simple sense, if you are dealing with columns, the lowest value of the column dominated the highest value of the column. In the third case, a pure strategy of the player may also be dominated if it is inferior to some convex combinations of two or more pure strategies. As a particular case, inferior to the averages of two or more pure strategies. In some situations, a single row may not be dominated the other row, a single column may not be dominated the other one. In that case, we have to take the average of two rows and compare with the other row or column and apply the same case. A highest number of rows will be dominated and lowest number of column will be dominated. So these are the basic rules are there for applying of dominance. And now we have to apply this dominance to the previous problem like this. See, in this case, after applying of this particular matrix, we didn't find the saddle point. So now we have to apply the dominance principle. First, we may understand or take row. Under row, what is the rule is highest number dominates lowest number. So this is the case. First one we need to compare A1 with A2. See under A1 and A2, A1 what is the value? 4 and A2 4. Under this 4 and 4 both are equal. That means we can say that A1 is dominating A2 and A2 is also dominating A1. So this is the first case. Means we compare the other number A1 2 and A2 3. In this case A2 is A2 is 3. That is A2 is dominating A1. Yes. Here under this particular point, if you take these two numbers, A2 is completely dominating the A1. See the third number 0 and 1. A1 is 0 and A2 is 1. That means 1 is dominating 0. So A2 up to 3 numbers, A2 is dominating A1. Next one. A1 2 and A2 3. So under this 3 is dominating 2. So if we take these 4 numbers, A2 is completely dominating the A1. Next one 1 and 2. A1 is 1 and A2 is equal to 2. That means here 2 is dominating 1. So here is up to 5 numbers, that is up to from B1 to B5, A2 is completely dominating A1. And take the last numbers here 1 and 2. Here the 2 is dominating 1. And if you see all 6 numbers of A2 is dominating A1. So we can say that A2 is dominating A1 row. So simply we can delete A1 row. Like if you see the matrix, previously the matrix is 5 by 6. Now it is reduced to 4 by 6. It is reduced to 4 by 6. So again we need to take another row, that is A2 to A3 comparison. A2 and A3, A2 is equal to 4 and A3 is equal to 3. So both are dominating each other, and take the another number 3 and 3 here. So both are dominating, and 1 and 7, here 7 is dominating 1. That means up to 3 numbers A3 is dominating A2. And if you see that here 3 and minus 5. So here the 3 is dominating, the 3 is dominating minus 5. That means A2 is dominating A3. But up to 3 numbers A3 is dominating A2. But here after A2 is dominating A5, yeah, A3. So that means no domination exists. No dominance. Take another A2 to A4 comparison. See A2, A4, 4 and 4, that is both are A2 is equal to 4 and A4 is equal to 4. So both are dominating each other. The second one 3 and 3, both are dominating. 1 and 4, yes. Here the 4 is dominating 1, that means A4 is dominating A2. And see 3 and minus 1, so 3 is dominating. That means up to 3 numbers A4 is dominating, but on the fourth one, that is under B4, 3 is dominating minus 1. That means no dominance. In the next one, A2 to A5 comparison. See A2, A5. So A2, 4 and A5, 4, both are dominating each other. Next A2, 3 and A5, 3, both are dominating. A2, 1 and A5. Here A5 is dominating A1 because A5 is having 3. And second, under B4, 3 and minus 2 is there. A2 is 3 and A5 is equal to minus 2. Now 3 is dominating minus 2. So in one case A5 is dominating, in another case A2 is dominating. That means no dominance exists. So A2 and A5 completed. Next comparison, A3 to A4 comparison. See here A3 and A4, A3 4 and A4 4. That is both are dominating each other. Second case 3 and 3, both are dominating. 7 and 4, 7 is dominating 4. That means we can say up to 3 numbers, we can say that A3 is dominating A4. But in the fourth number minus 5 minus 1, that means minus 1 is dominating minus 5. That means A4 is dominating A3. In up to 3 numbers A3 is dominating, but on the fourth number A4 is dominating A3. So that means we can say that no dominance. Next comparison, A3, A5. A3, 4 and A5, 4, both are dominating each other. And A3 and A5, that is 3 and 3, both are dominating. 7 and 3, so 7 is highest number, 2 is the lowest number. So 7 is dominating, that is A3 is dominating A5. And here on the fourth minus 5 minus 2, that means minus 2 is dominating minus 5. That means A5 is dominating A3. Up to 3 numbers A3 is dominating, but here after A5 is dominating. So that means we can say that no dominance exists. So next comparison, A4 and A5. So A4 and A5, A4, 4 and A5, 4, both are dominating each other. Next 3 and 3, both are dominating each other. 4 and 3, so 4 is dominating. 4 is the highest number, that means A4 is dominating A5. We can say that minus 1, minus 2. Here minus 1 is greater than minus 2. So that means A4, up to 4 numbers, A4 is dominating A5. And next one 2 and 2, both are dominating each other. And last one 2 and 2, both are dominating each other. And if you see that 4 numbers, that is 4, 4, 3, 2 and 2, all are dominating each other, but remaining the middle points. See here 4 and 3 and minus 1 minus 2, here 4 dominating minus 1 dominating. That means most of the cases A4 is dominating A5. So we can say that A4 is dominating A5. So we can easily delete the A5 row like. So now the row matrix reduced to 3 by 6. 3 by 6. So this is the way to reduce the dominance. So here the row process completed, and now we move to the column process like this. See here the matrix is reduced to 3 by 6. Now we can see the column dominance or not. So here, and what is the rule here is lowest number dominates highest number. So here there are B1 to B6 is there. First comparison B1 to B2 comparison. See under B1, B2, 4 and 3. Which is the lowest number? 3 is the lowest number. 4 and 3, 3 is the lowest number. And again 4 and 3, 3 is the lowest number. That means we can say that B2 is completely dominating B1. B2 is dominating B1. That means we can delete B1 here because the lowest number or lowest column dominates the highest column. So we can delete B1 like this. Here the matrix is reduced to 3 by 5. So next comparison B2 and B3. So B2, 3 and 1. So 3 is the highest number and 1 is the lowest number. That means B3 is dominating B1. 3 and 7. Out of 3 and 7, 3 is the lowest number and 7 is the highest number. That means 3 is dominating 7. In the first case, B3 is dominating B2. In second case, B2 is dominating B3. So you can say that no dominance. So next comparison B2 and B4. So under B2, B4, 3 and 3. So both are dominating each other because if the same numbers are there, both are having equal dominance. So B2 is dominating B4 and B4 is dominating B3. Second case 3 and minus 5. So here minus 5 is lesser than the 3. So that means we can say that minus 5 is dominating 3. So we can say that B4 is dominating B2. And last number 3 and next one is minus 1. So here the minus 1 is dominating 3. So that means we can say that B4 is dominating B2. So finally B4 is completely dominating. B4 is completely dominating B2. So we can delete B2 here. So now the matrix is reduced to 3 by 4. So next comparison B3 and B4. So B3 and B4, B3 1 and B4 3. So you can say that 1 is dominating 3 and B3 is dominating B4. Second case 7 and minus 5. So minus 5 is dominating 7. So that means in one case B3 is dominating B4 and second case B4 is dominating B3. So we can say that no dominance. So next comparison B3 and B5. So B3 1 and B5 2. So the B3 is dominating B5. Second case 7 and 1. So B5 is dominating B3. So simply no dominance. Next comparison B3 and B6. So B3 1, B6 2. 1 is dominating 2. So B3 is dominating B6. Second case 7 and 2. 2 is dominating 7. That is B6 is dominating B6. In one case B3 is dominating B6. In the second case B6 is dominating B3. So we can say that no dominance. So next comparison B4, B5. So B4 3, B5 2. That is B5 is dominating B4. Minus 5 1. B4 is dominating B5. So no dominance. Next comparison, B4, B6, 3 and 2. So B6 is dominating B4. Second case minus 5 2. So that means B4 is dominating B6. So we can set that no dominance. The last comparison, B5 to B. So B5 to B6 to, that is both are dominating each other. Second case 1 and 2, that means 1 is the lowest number. So B5 is dominating B6. Last number 2 and 2, B5 is dominating B6 and B6 is dominating B5. But one case here the 1 is there. One is the lowest number of B5 and there is no lowest number here. So finally we can say that B5 is completely dominating B6. B5 is dominating B6. So we can delete B6 here like this. The matrix reduces to 3 by 3. So column process also completed. So we may move to the next level of dominance. See, the total matrix is reduced to 3 by 3. Again apply the dominance, row dominance, comparison A2 to A3. So A2, 1 and 7, that is A3 is dominating A2. And here 3 and 5, A2 is dominating A3. So we can set that no dominance. Next one, A2, A4 comparison. A2 1, A4 4, that is A4 is dominating A2. And here 3 and 1, A2 is dominating minus 1. That means no dominance. In one case A2 is dominating, another case A4 is dominating. That's the reason no dominance exists. The last comparison of row is A3 and A4. See here A3, A4, 7 and 4. 7 is highest number, 7 is dominating 4. And next one minus 5, minus 1. Minus 1 is dominating 5. That means one case A3 is dominating A4 and second case A4 is dominating A3. So no dominance. So under row there are no dominance exists. So immediately we can calculate column also. Column dominance B3, B4 dominance. B3 1 and 3. So 1 is dominating 7 and minus 5. Minus 5 is dominating. So in one case B3 is dominating B4. In second case B4 is dominating B3. So we can set that no dominance. Next comparison B3 to B5. 1 and 2. So 1 is dominating 2, that is B3 is dominating B5. 7 and 2, 2 is dominating 7. So B5 is dominating B3. So no dominance exists. The last comparison B4, B5. So 3 and 2, 2 is dominating 3, minus 5 and 2, minus 5 is dominating 2. So in one case B5 is dominating B4, in second case B4 is dominating B5. So no dominance. So what we understand here is, if we apply row and column dominance, there is no dominance exists. So how can we reduce the matrix? Other than this is, we have to take averages. So row average. So average of A2, A3 compare with A4. See here, what is the average of A2, A3? 1, 7. That is equal to 8. 8 by 2. Average is equal to 4. Second one, 3 minus 5. That is minus 2 divided by 2. That is minus 1. These are the new numbers of the average. Next 2, 2, 4, 4 by 2. That is equal to 2. So these are the numbers. And compare with A4. So what are the A4 numbers? 4, minus 1 and 2. This is the average of A2 and this one is A3. And if you compare this, Average of A2, A3 is 4 and A4 is 4. That means you can say that both are competing each other. Minus 1, both are competing. Both are same values, that means both are competing. 2 and 2, both are same, that is both are competing. So finally, how can we get these values? 4, minus 1, 2, these are the averages. So we can say that average of A2, A3 is dominating A4. So we can simply delete the A4 row. Now the matrix is reduced to 2 by 3. So up to this we can stop the row dominance because the minimum of rows is 2. So we achieved this target. But here if you see the column, there are 3 columns are there. So again try to reduce this column to 2. Column average. Average of B3, B4 compared with B5. So 1 and 7, 8, 8 by 4, 8 by 2, that is 4. So B3, B4 average, that is 1 and 3. 1 plus 3, 4. 1 plus 3 is equal to 4. 4 by 2, that is equal to 2. Next case is 7 minus 5, that is equal to 2 divided by 2, that is equal to 1. The new numbers are 2 and 1. And here B5 is equal to 2 and 2. And if you compare this average B3 and B4, 2 and 2, next one is 1 and 2. So the first one is 2 and 2, both are same, and 1 and 2, 1 is dominating 2. That means we can say that average of B3, B4 is dominating B5. So we can simply delete B5 here. Now the matrix is reduced to 2 by 2. So we successfully reduced the matrix to 2 by 2. So this is done. And now we can write the thing like this. So A2, A3 and A4. So finally we got this A2, A3, B3 and B4. So this is the final matrix we got. And again check that whether this particular problem is having saddle point or not. So for that purpose, row minimum, column maximum. Under row minimum, identify the lowest number, that is 1 and 5. Out of this, you need to find out the maximum number 1. This is referred as maximum. And the column maximum, identify maximum number 7, 50. Out of this, we need to find out the minimum number, that is 3. So 1 and 3. So we can say that maximum is not equal to minimax. So this is minimax. That means 1 not equal to 3. So we can say that a game without saddle point. And what is another thing is there is no value to this game up to this extent. So we need to identify the value of the game by using some graphical method. So this is using graphical method that and apply the three methods of the game theory. So what are the three methods is algebraic method, arithmetic method and analytical method. So see the videos on this methods so we may get more clarity on how to solve a game by using various methods. Thank you for watching.